Every single day we throw stuff away without a second thought. But what if all that trash wasn't an ending? What if it was actually a beginning? In this explainer, we're tackling a massive question. Can we actually turn our global trash problem into a valuable resource? Let's dive in. To really get a handle on the scale of this, just look at that number, 2.01 billion tons. That is how much municipal solid waste, the everyday trash from our homes, schools, and offices, humanity turns out every single year. It's an absolutely mind-boggling amount. And frankly, it's only growing.
So, the big question is, where does all that stuff end up? For a long time, the answer was, well, pretty simple and also pretty awful. We just dig a giant hole and bury it. Landfills. But we're running out of space, and we're finally waking up to the huge environmental cost. So the hunt is on for much, much smarter solutions.
And that brings us to a pretty interesting idea. It's called refuse-derived fuel, or you'll often hear it called RDF for short. So what exactly is RDF? Well, put simply, it's fuel that's made directly from our garbage. The whole process takes that mixed-up municipal solid waste, sorts it, treats it, and turns it into this uniform, burnable material. And that material can then be used to generate electricity or heat. It's a technology that literally creates power from our trash.
And this is really the key mindset shift here. The whole idea behind RDF isn't just about making our trash disappear. It's about transformation. It's about looking at a pile of garbage not as a problem that needs burying, but as an overlooked resource that's just waiting to be used.
Okay, that all sounds great in theory, but how does it actually work? I mean, how do you take a random bag of household trash with banana peels and junk mail and turn it into a consistent, usable fuel? Let's walk through the process.
First, you have to know what you're working with. A typical trash bin is, a total mix of stuff. But a lot of it is actually combustible. Things like paper, cardboard, plastics, and even food waste. The trick is separating all that good stuff from the things you can't burn, like glass and metal. Those have to come out.
So picture a kind of production line for trash. It all starts with sorting. Big magnets pull out steel, air jets might separate lighter plastics, and screens filter out different sizes. The goal is to get rid of anything that won't burn. Then, whatever is left gets shredded into small, uniform pieces. After that, it's dried out to remove moisture. This is super important because drier fuel burns hotter. And finally, all that fluffy material often gets squeezed into these dense little pellets or bricks, which makes them way easier to transport and use in a power plant.
But of course, it's not quite that simple. Like any technology that mixes waste and energy, RDF is at the center of a pretty heated debate. So let's get into it and look at the promise versus the potential peril.
Let's break down both sides. On the one hand, the promise is huge. It dramatically cuts down on how much stuff we have to bury in landfills. It creates a local energy source from something we have way too much of anyway. And it gives us something to do with all that low-grade plastic and mixed paper that's really hard to recycle. But on the other hand, the perils are very real. Burning waste, even processed waste, can release harmful emissions if you don't have top-of-the-line filtration systems. It's not renewable in the same way as wind or solar because it relies on us making more trash. And maybe the biggest concern? That if we get too good at burning trash for energy, it might make us less motivated to reduce, reuse, and recycle in the first place.
So where does RDF really fit in, environmentally speaking? Well, when you compare it to a landfill, which leaks tons of methane, a really potent greenhouse gas, a modern RDF plant is definitely an improvement, no question. But as you can see, it still creates emissions. It can't compete with the near-zero impact of true renewables like wind and solar. So you can think of it as a step up from the old, bad way of doing things, but it's not the ultimate green solution.
So where does all of this leave us? Let's zoom out for a second and look at the bigger picture. Could RDF really be the future of fuel?
Maybe the healthiest way to think about RDF isn't as some magic bullet solution. It's better to see it as one important piece in a much bigger puzzle, what people call the circular economy. In a perfect world, in a truly circular system, we would design waste out of the equation completely. Everything would be reused, repaired, or recycled. But let's be realistic. There's probably always going to be some leftover stuff that can't be recycled. RDF gives us a way to squeeze one last bit of value out of that material, closing the loop instead of just throwing it in a hole in the ground.
All right, let's boil this all down. What are the key things to remember? First, RDF is a technology that takes our non-recyclable trash and turns it into energy. Second, it's a very real and immediate alternative to our landfill crisis. Third, that environmental debate is critical.
We have to be honest about the risks of emissions and the impact on recycling. And finally, it's probably best to view it as a bridge technology. It's not the final destination, but it could be a crucial bridge to get us away from landfills while we work toward a truly circular future.
So we're back where we started. Is our trash the fuel of tomorrow? As we've seen, it's a really powerful idea, but it comes with serious trade-offs. Maybe the real challenge isn't just about turning our trash into treasure. Maybe it's about building a world where we create a whole lot less trash in the first place. Now that would be the real treasure. Thanks for joining me.